Let's find the optimal Hamilton circuit using the brute force method. Now, the brute force method isn't too bad. We're going to list all Hamilton circuits. Then we're going to find the length of each circuit by adding the edge weights. And then we're going to select the circuit with the minimal total weight. Great. I love this. Let's do this. Let's apply the brute force method to find the minimum cost Hamiltonian circuit on the graph below. Now, recall from past lives that in this particular case, we have 4 vertices. So that means n is 4. So if I would take 4 minus 1 factorial divided by 2, this tells me how many distinct or unique Hamilton circuits there are. So 3 factorial over 2, well, 3 factorial is 6. 6 divided by 2 is 3. So I know there are 3 distinct Hamilton circuits. Great. Let's check this out. So the first one, well, I'm going to use B as kind of my starting point, okay? So if I would go B to C to A to D to B, right? Because it's a circuit. So B, C, A, D, B. Well, what is the point value of that? 1 plus 6 plus 3 plus 17 gives me a value of 26. Okay. So from B, I have another option, right? I could go A, D, C, B. So B, A, D, C, B. So that's 8 plus 3 plus 12 plus 1. That's 24. Then I could also find B, B, A, C, D, B. B, A, C, D, B. So that's 8 plus 6 plus 12 plus 17. Notice, unique. They're all different. So 20, 37, 43. So when we look at the 3 different ones, because remember, forward or backwards doesn't matter. So if I started with B and went to D, you can see that this one goes B to D, this one goes B to D. So they're backwards, right? You can go backwards, forwards, it doesn't matter. They're still the same. So when I look at the 3 of these, the optimal using brute force method would be the BADCB because that's the weight of 24, which is the smallest. Let's do one more. Use the brute force method to find the cheapest price to move between all 4 cities. Okay, so again, we have 4 vertex points. So just like we did before, we're going to have 3 unique circuits. All right, so let's start with A this time. Excuse me. So if I would go A, B, D, C, A. So that's A, B, D, C, A. So 74 plus 47 plus 51 plus 62. That gives me a total of 234. So that's the first one. All right, well now let's stick with A being our starting point, but instead of going to B first, let's go to D. So A to D to C to B to A. Okay, so A to D, 26, C to D, 51, C to B, 30, and then B to A, 74. That gives me a total of 181. And then, if we would start again at A and go to C, to B, to D, to A. Did I get them all? All right, so A to C, to B, to D, to A. Okay, so A to C is 62, C to B is 30, B to D is 47, and then D to A is 26. And that gives us a total of 165. So you can see that that one is actually the lowest because it avoids the AB, which is 74 and the most expensive. So that last one, ACBDA, or you could do it backwards, ADB, CA, right? Doesn't matter, but that route is the cheapest of our 3 unique circuits.